Hello everyone. We are at the Go Meetup, so I'm assuming that all of us love Go. We all believe that Go is the best invention since the invention of sliced bread, that all the other languages are actually useless and everyone should be using Go. And you would be right, but those are just technical arguments. There are other arguments for using Go, and one of them is money. And that's what I'm going to talk about. My name is Yigal Duppen. I've been a Gopher since 2013. And in 2015, I got a call from someone I didn't know through LinkedIn. It said, hi, I've got a company, I've got an ID, I've got prospective customers, I just need some technology. Do you want to join me? IDs are cheap, having customers is not, so this sounded interesting. We got talking, and since 2015, I'm actually the CTO of this company called Door2Doc. It's a bootstrapped service, software as a service company, which means we're doing it in our spare time, so I'm only spending 1 day a week on it. And we basically provide informatics and analytics for urgent care in healthcare. This is quite broad, but stuff like when you go to the emergency care in the hospital, you want to know how long is it going to take, when will they help me. We provide that kind of information. When you're running an emergency care at a hospital, this is called, by the way, unplannable care in technical terms, and we've decided that it's not really unplannable. You can do a lot of analytics in advance to make some kind of planning, because in the end, you usually get approximately the same number of patients on the same times, funnily enough. Right now, all of this is focused on Dutch healthcare. I'm originally from Amsterdam, as you can hear from my lovely accent. And right now we are running for 7 locations, and we're slowly growing. So that's Door2Doc. I'm not here to talk about Door2Doc, I'm here to talk about Go. So what I'm going to do is I'm going to sketch the background of this talk, and the background of why I needed to choose a language in the first place. I'll explain the criteria I used for coming to the right language, this being Go. I'll show you how this actually worked out for us. And for me, the most interesting part, part 4, I'll show you some accidental savings, stuff that actually helped us make more money because we use Go. So the background. We started out with a prototype, which was based on a simple machine learning model, linear regression, to predict waiting times at one specific hospital. And all we needed was a proof of concept to show, yes, given a live stream from your database, we can actually show that to your patients. We didn't have a lot of time to do that, so I made a prototype in Django. If you don't know Django, it's a framework in Python that helps you create web applications backed by a database quite fast. It's a neat project. I like it a lot. I've done a lot with it. So it was a good choice to quickly make a prototype. We initially ran it on a single server on DigitalOcean. A bit later, we moved to a cloud provider, an OpenStack provider that had some more provisions on how they dealt with their data. And the client, or at that stage, the client uploaded the anonymous data through a simple upload. And that allowed us to show at every time the approximate waiting time for patients. And the customer was very happy with that. So they wanted more. And other hospitals learned about this, and they also wanted to join. And at that point, we had to grow a little bit. And we quickly realized that what we wanted was a SaaS solution, which is not very typical in Dutch hospitals. They usually want to keep all their data to themselves in their own data centers, in their own basement, which can then flood, because basements tend to flood in the Netherlands. This is a real story. No, I kid you not. So this was already a daring suggestion, but if you have one day a week, you don't have time to go run around and do installations at all the different hospitals. We also wanted high availability for a simple reason. The cloud provider I was talking about that provided good guarantees on what they did with your data did not provide very good guarantees on the uptime of their network, which was problematic because we had a lot of downtime. And when you're a new company that tries to sell yourself to new customers, downtime is not a good thing. You have to imagine that the big hospitals are basically running one of three types of big systems, huge systems that already have a tendency of going down, and they already have a tendency of causing the IT department to spend a lot of time keeping them up and running. They don't want another product that goes down at the wrong moment. So we needed some kind of high availability. And the kind of questions we got from the different customers and prospective customers made us realize that we needed to be able to quickly iterate on all kinds of different unrelated features. And when you combine all that, you get to a simple conclusion. We need to run on a professional cloud provider that provides multiple availability zones, and we need a microservice architecture. And I asked myself the question, do I want to do that using Django? Now, of course, Betteridge's law of headlines. If you ask the question, the answer is no. And asking the question is also answering it already. I did not really want to continue with the prototype we had in place because it had a lot of problems. So I wanted to make sure that Go was indeed the right solution, so I did a small exercise, which starts by a small cost analysis. What are the primary costs when creating a SaaS company? And it's really, really simple. The full-time equivalents of developers you have, the more time you have to spend programming, the slower you go. And infrastructure. Infrastructure on a cloud provider. It's cheap. It's cheaper than doing it yourself, especially at our scale, but it's still expensive. So we want to reduce, well, I wanted to reduce development costs. Keep in mind, at that point, I was the only developer. So when I say reduce development costs, I really mean reduce the time I spent developing this stuff. And this starts with choose a language you know. And I know quite some languages, some very well, some not so well. And that already helps narrow it down a lot. For example, we're doing a lot of data modeling and mathematical transformations. So I could have chosen something like Haskell, which is really good at that. But I'm not really good at Haskell, so starting a company based on that language is not a good choice. Which means I ended up with one of three options, Java, Python, or Go. The second one is I really wanted to minimize framework magic. If you've ever worked with Spring Boot, for example, it's really easy to get started, and at a certain point you want to do something slightly different, and 3 weeks later you finally find out why. This was an actual problem I had, by the way. I was using Django DRF, the Django REST framework, which is a great framework if you do exactly what they intend you to do. I needed to do something different. I later on had to debug that. And if you write really smart code, it will take you at least twice as long to debug that, if ever. Which made me realize I need to prevent myself from being clever. Being clever sounds cool, it's not. I wanted to optimize CI/CD for the simple reason that I don't trust myself, especially not when doing deployments on production systems. So I want to automate that. And tuning costs. Some software you have to tune the hell out of it to make it function as you want, and other software you don't have to do that. I'm really bad at tuning, so I didn't want to do that. Those were basically my criteria for how to reduce or minimize the costs on development that are not directly related to providing new functionality. The other one is reduce infrastructure cost, and the first one, when you want to reduce infrastructure cost on a hosted cloud provider, is to minimize your memory footprint, because RAM is the single most expensive part of your virtual machines. You also want to minimize latency, not because of the latency itself, but because latency usually involves CPU activity, and that can also quickly add up. And finally, you want to minimize the payload, because bandwidth is also expensive. It's crazy how much of this stuff is actually expensive. And my conclusion was, let's use Go. I already knew this conclusion before I started this exercise, but it was still a good exercise. But did it actually work out? Well, it did. For example, about minimizing the framework magic, we've got about 14, 15 Go services running now in production. And so I just looked at their dependencies. And these are the most common dependencies. Gorilla Mux, just a slide add-on on the basic HTTP routers. Prometheus client Golang, which just exposes metrics on your application to Prometheus, so I can do some metrics analysis on my operating system, or on the running system. libpq, which is a driver for Postgres. Ocarina Go CSV, which is a very cool CSV library, and I shall tell you more about it a bit later on. And PKG errors, because when I started, we still had the old errors. And it's nice to annotate them to get a sense of what is going wrong. So on this level, minimizing framework magic, I feel quite content. There are no frameworks, so no magic there. Minimize CI/CD. This is basically my entire CI/CD environment. I'm lying. There's two more parts. I've got a Jenkins file. I'm running Jenkins. And the Jenkins file consists of 3 lines. Line 1, build the Docker image. Line 2, upload it to the registry. And line 3, deploy it from the registry using Nomad. That's all the Jenkins file does. I have a Nomad specification, which is a bit like Kubernetes, but better. And I got this Docker file, which is basically the same for every single service. And I'm going to quickly run you through it because it contains some interesting stuff. The first 2 lines are not that interesting. Third one, yeah. The 4th line, run go test minus short. I can basically run all my unit tests while I'm building the Docker container because Go testing is so incredibly fast. And then I install the stuff. I create a new container, copy it from there. And then at the bottom, I run a special command. On that service, a test command, which tests if it has been installed correctly on the image. I will get back to that later. And I basically run the service. That is all it's doing. This is taking me about, well, from push to master to running on production. This takes about approximately 5 minutes on really underpowered servers. Really underpowered, yes, the entire service mesh is running on 2 T2 medium machines. We're running on AWS, if you recognize the terminology. T2 medium basically means extremely cheap, but not as cheap as small. We have 1 RDS instance, which is our database, and then we have 3 tiny instances running around to manage the cluster itself. The average latency is around 20 milliseconds. We have about 1,000 requests per hour, and I realized that this is not, well, not a very impressive load. But I got a huge amount of CPU power left. I got a huge amount of everything left, and we can easily onboard twice as many clients as we have now without any issues. So on the infrastructure cost side, we are happy. Also, the T2 machines, they are burstable machines, which means that you basically have CPU credits, and when you use CPU, the CPU goes down, and over time you accrue new credits. So if you use less CPU than you have credits, then your machine is happy. If you use more CPU than you have credits, your machine grinds to a, well, to a crawl. And our CPU credit usage is consistently below accrual, which means that all our machines are running at maximum capacity, basically, which is nice. Memory usage, I told you, RAM is also expensive. 14 Go services, and they got 1.2 gigabyte allocated to them. This is allocated memory, not memory they actually use. I tend to heavily over-allocate memory on the Go side. So most of them are actually using, most of them have allocated 50 megabytes and are actually using 25. And we've got 1 outlier on 500 megabytes. There's still some Python running, especially on the machine learning part. And those also take 1.2 gigabyte, but that's only 3 of them. And I could probably get that down a bit, but then we get to all the tuning parts, which I'm really not good at. So I haven't done that, and basically Go shines here. Also realize that most of those services, I don't have just 1 running. I've got them running at least twice because of high availability. And the most important part, is the developer happy? Yes, I am. Which concludes my evaluation. Now, this is all very nice, but much more interesting are the accidental savings, stuff you realize when you're developing Go, that your life is actually getting a lot better because you are using Go. The first one, expressive tests. This is a part from an actual test case. It's partly in Dutch, which is not a problem. It's a table-driven test for calculating or actually verifying waiting times. So we have afspraken. This is Dutch for appointment. Take notes. If you follow this entire presentation, you'll be fluent in Dutch. And it requires a slice of afspraak interfaces, which we have implemented in a completely different way than the official afspraken. This simple struct, it's not defined here, but it's basically a container for only the data that's actually relevant for this part of the algorithm. So I don't have to construct huge setups to be able to test my logic. So given these appointments around 12:33, I expect that the average waiting time is 15 minutes, based on the patient status fields that I've got there, and the urgency of the patient, which basically indicates is he dying right now or in 50 years. And the fun part of this test, well, I find it very fun that I don't have to write huge test setups. That's always nice. Much more interesting is my business partner. He can do things with Excel that will amaze you, but he cannot code. But he can read this. So I can just show him my test cases, and he can look at them and say, yeah, that's wrong. That's not what I meant. Or sometimes he says, yeah, you're right. That's how it should work. So expressive tests. And this, using these tests as a means of communication makes my life a lot easier. There's a fun tool, it's called Precommit, and it helps you install Git commit hooks. And in my case, it does a Go format and also a complete unit testing of all the code I'm about to commit. I am lazy. From time to time I forget to run my tests. The pre-commit hooks do not forget this, which gives me a lot of confidence that what I check into Git is actually correct. Of course, it only works if your tests are fast, but that's actually quite easy to accomplish in Go. Slightly related to the previous presentation is type definitions. And I think this is one of the most underestimated features of Go. The fact that you can redefine basic types into another type. And this, for example, I've got two types here, correlation ID and age group, which underneath are both integers, just 4 bytes somewhere lying around. But by explicitly typing them like these, I will never be able to mix them up without the compiler slapping me in the face, because that would be wrong. And this is especially important because data is often really, really badly structured when you get it from another party. We all know our own data is perfect, but the data from other parties is not. And this helps you make sense of it. Especially because now I can also define my own JSON marshalling, for example, and JSON unmarshalling. So if they happen to pass me a string instead of an int, I can just parse it while I'm deserializing it. And that is an absolute time saver, not to mention the amount of compiler warnings that save me an afternoon of debugging. Another great feature of Go is the context. It's also somewhat underappreciated. When I ran this Django application, I noticed that from time to time I had queries running on my database that had been running for days. Probably because the one that did a select on the queries was dead by now. I don't know. I never found the time to find out why. But the solution was, well, look at the Postgres activity statistics and kill all running queries, which is fun to do, especially if you're not really sure if the query should be killed, and especially if you don't know why this is happening. In Go, when you start a transaction, you have either the db begin from the SQL package, or you have begin CTX, where you pass in the context, and if the context is cancelled, the transaction is guaranteed to be cancelled. And when I say guaranteed, I mean that in practice, I've never seen that fail. And I've never, ever, ever had this problem again since I was using context-bound transactions. I can also bound those. Well, I can get if I want. In some cases, I want that get that context from the current incoming request. So if upstream cancels the request, my transaction is also cancelled. Everything is clean. Makes me very happy. And the last one that I'm gonna tell you a lot about is, I think, the most interesting one, and that's admin screens. Basically, every application I've ever worked on had stuff that needed to be tweaked by people other than developers. And I've basically seen two approaches to this. Approach number one, put it in property files and have someone restart the application. Well, putting stuff in property files can still be done by the product owner, usually. Restarting the application, you usually do not want to leave that to the product owner, so that would, in practice, mean I would have to restart an application. Not looking forward to that, especially because I like to have this stuff in a managed environment. The other approach is writing admin screens, where you have this web interface where business owners can tweak the values completely outside of any form of configuration management, so you never know what's actually running in your system. Also not something I wanted. Now I mentioned my business partner, he can do stuff with Excel. And he also understands CSV. And I got him to understand GitHub Desktop, or at least the basics, because it's not that hard. And so instead of property files, I have CSV files in a specific directory called data, and the deal is he can do with those CSV files whatever he wants. And when he commits them to master eventually, that stuff gets deployed into production. And as you saw some time back, let me scroll back. Those are the last two parts in my build environment. I add that data to my container. I make sure that when I interpret the data, it's A, readable, and B, it makes a reasonable amount of sense. And if that's true, we deploy it. And if then in production it turns out to be false, we just revert it, because reverting is also easy. This means that we have a managed solution for configuration data that can be managed by the product owner without me being even near a computer. And most importantly, it means that I did not have to write administration front ends, which I really hate. For that I'm using, I already mentioned, Ocarina CSV. It's a very tiny library which basically uses struct tags, just like the JSON marshalling. It's basically JSON marshalling for CSV, and it works great. And if you ever have to do something with CSV, please use that. It's really good. Now there's more. The list goes on, but I knew I only had half an hour. So I'm just going to mention them quickly. Using channels to stream database result sets for some operations, I need to analyze a huge amount of data in memory. I can either increase the amount of memory. I felt bad about that. You can start paging your result sets. I hate that. Or you can start using channels and everything is fine. For some parts we're using WebSockets, and combining them with channels makes it super easy for any part of your application to just say, hey, notification, and it gets picked up on the other side and sent out over the WebSockets. I already mentioned the possibility of overriding Marshall JSON. I'm now seeing that I try to do Markdown in Keynote. Interesting, that doesn't work. Overriding Marshall JSON means that you can decouple your view from your internal model quite easily without having to copy data all over the place. You just have your Marshall JSON function, which does the munging you need. Mockless testing, thanks to Go interfaces, I hardly ever need mocks and still get a huge amount of coverage. And the list goes even further on, but well, at some time we really want to have a drink. So thank you for listening. And are there any questions?
Question. Very far up top, all right. This is my training program for today.
There you go. Thank you, Michael. Have you considered working more than a single day per week on your startup?
Sorry, come again, I couldn't hear you.
Yeah, have you considered working more than a single day per week on your startup?
I have considered it. I also have to make money. We are bootstrapped, we don't have external investors, so all the money we get is from the money we get from our customers. So right now it's one day a week. Once we have enough customers, that amount of time will grow.
More questions?
Okay, thank you very much.
Over here?
Oh,
sorry.
Sorry.
Are you using Go mod, and why not?
Sorry, am I using?
Go modules?
I am using Go modules, yes. I'm also using them in the vendor mode for the simple reason that I don't want my CI environment to start downloading my dependencies if it's really not necessary. So yes, I'm using Go mod. Sorry? Could very well be. Okay, thank you very much.